Hello, good morning, my dear thinkers. On this 8th May 2026, I am so happy to connect you all, make you all understand more detailed way all about circuits, various circuits. So, I hope you all remember yesterday we worked with the circuit book to understand circuits. A day before, we worked with basic circuits. And on the board and on the TV, I have explained all that. But today, I am going to make you understand all about circuits, various circuits, making use of this snap circuits. This is one of the good kit for students to understand all about the electrical and electronic do-it-yourself project making. That's why, being a mentor, I said let me transform my mentees to make them understand basically how practical world works. As I already told in the first session, that we have some electrical components and electronic components. So you need to understand what all the various electrical components. So these resistors are electrical components. And these capacitors are also electrical components. Okay? But however, here is a bulb, electrical bulb. This is a filament, Thomas Alva Edison invented incandescent filament bulb. Okay, but however, this is a semiconductor device, LED, light emitting diode. Okay, so there is a difference between these two bulbs. This is a regular bulb and this is a light emitting diode. So there is a difference between them. And here, to make it glow, current can be passed from here to here through the filament or from here to here also. Both the directions current can pass through because that's a simple resistance inside. So through the resistor, current can always pass from one side to the other side to left to right, right to left. So it doesn't have any one directional control. So this bulb is the regular bulb is similar to a kind of resistance. Okay. But however, when current is passing through the resistor, you will see some heat on the resistor. But however, the same phenomena in this bulb you will see the light and heat both. But of course this is developed for giving you the light. But in the original invention done by Thomas Alva Edison, so whatever energy you are spending across this, only 5 to 10% is getting converted to light, rest is getting heated. That's why it is invention, but however it's an innovation. In this innovation, most of the energy is just getting converted as light, not to heat. That's why these days LED lights, LED bulbs are more popular. Because with less energy, more the light. If the same amount of light, if you wanted to get from this, then suppose you need to spend 100 watts, the same amount of light you will get from this by spending 10 watts. So you will save 90 watts using LED bulbs, getting the same amount of light. You understand? So anyway, yesterday we have discussed all about the resistors. Resistance in the circuit is to oppose the flow of electrons, flow of current. Whenever we wanted to allow more current, we had to increase or decrease resistance. Whenever we want to allow more current, more the bright. When we wanted to keep the LED more bright, we need to make the resistance less or more?
Less.
Less, very good. Arish, what is your answer?
Less.
Okay, if I increase resistance more in the circuit, then what happens?
The light will be dim.
Because that resistance is opposing flow of electrons in the circuit, in the basic circuit. That's why the lesser the current, lesser the bright. This is what we have discussed yesterday. You understood? Okay, anyway, now coming to the another point, what are the purposes of these capacitors? And there are some capacitors you see like a small battery, cylindrical shapes. You see? They are called electrolytic capacitors. They are called electrolytic capacitors. The capacitance of this kind of capacitance is high than the capacitance of this kind of capacitance. They are called disc capacitors. They are ceramic capacitors, disc capacitors. They don't have any polarity. Any side direction, you can use them. But however, here with this electrolytic capacitors, you cannot use the way that you can use a resistor or this ceramic capacitor, disc capacitor, because the capacitance is so low, so we can use them in any direction. But here in this case, electrolytic capacitors, the capacitance is in the order of microfarads, but here it is in the picofarads, very less. So it is microfarads, little bit more than the capacitance of that value. That's why it will have plus minus. That's why you see they have written plus here, and you can see the plus on the capacitor also. Okay, similar to that, and rest is the minus. Okay, so capacitors will have, electrolytic capacitors will have the polarity. What you need to understand? Polarity. Similarly, diodes will also have the polarity. Like similarly, the LED is also a kind of diode. That's why this will also have the plus minus or anode and cathode. Okay, you understand what I mean to say? Good. Now, how can we make use of all these parts, electric and electronic parts? That's another important question. But before going to that, I wanted to make you understand about switch. This is a switch. Okay, this is a switch. So we can keep it on, nothing but these 2 points got connected internally. When it is off, the points are open. When it is on, then internally the both are connected, this point and this point. That means the internal wire connection established. So current allows. That means the circuit is closed if you keep it on, okay. But in similar to that, I have another switch. But this switch is not unlike that switch. Suppose in this switch, if you keep it on, that's it. Current is continuously going on. But here in this switch, the current will go, the connections are on, connected together, only during the time of only if you keep pressing it, then only that will be on. If you leave it, again the connection is off. But in that case, it's not like that. If you just off, it is off. As long as you make it on, okay. And it is on means on till you make it off. But however, in this case, no, it is not like that. The connections will be on only during the time you keep pressing it. If you leave it, they are open. So it is called momentary switch. Push it, push to on. It will be on only for the push time. If you leave the push, that's it. It will be off. So it is required for some purposes. Like for example, calling bell. Suppose if anyone press the calling bell, if you keep it on and it will go away, your calling bell will be continuously ringing. So if you use this switch, if someone comes and he will press and he cannot hold it for more time, no? If you wanted to go away, you will have to leave and go. By the time that will be off if you are not at home. Or if it is ringing, you will come and open it. You can. So that is a simple example for you. Later I will make you understand where all the places, like calculators, we use the calculators. In the calculators, or earlier in the phone also we have such kind of features. Laptop buttons, all the keyboards, right? They are all such kind only. Okay, if you press that A, then signal of that A will go to the motherboard. Okay, likewise, good thinking. Right, now making use of this, we wanted to establish some circuits. So, what you need to understand, so connecting some, wires for the required. Yesterday we have discussed in the basic circuit, what all the components we have used, a battery, okay, battery. Anything else we have used than the battery? Okay, I am going to keep the battery here, okay. Okay, I have inserted the battery compartment here. So the pushing, I can remove it, no? I can remove it. And I can again push it back. So, why it is called snap circuits? Snapping is nothing but, like this is called snapping. What is this called?
Snapping.
Snapping is always nothing but
Pushing and removing.
చూడండి మన షర్ట్ బటన్ లాగా ఇక్కడ ఉన్నాయి. అవి మనం ఎన్నిసార్లైనా అలా పెట్టొచ్చు, తీయొచ్చు. మనకు ఉంటాయి కదా, మన కోట్ బటన్లు ఉంటాయి కదా. సో దట్స్ కాల్డ్ స్నాపింగ్ ద ప్రాసెస్ ఆఫ్ యూజింగ్ లైక్ దిస్. ఓకే, సో దిస్ ఈస్ కాల్డ్ స్నాపింగ్. సో we are using the technique of snapping. That's why they have named this kit as snap circuits. So circuits are getting snapped. That's why this entire kit is called snap circuits. You understand? Okay, now I must thank to my friend Tinku for sending this kit from America. Now, where is the positive? Here is the positive. Yesterday, from the battery positive, what has to go? I can also use this way also. Okay, I have the battery positive here, negative here. But let me check whether my batteries are working or not. Okay, let me check that. So I have a digital multimeter. So what I can do with this? I can check the batteries. Like yesterday we have seen, right? So to measure the batteries, I have to keep in 20. Okay. Because these two batteries are in series. We wanted to see how they are series. You see, I have removed the batteries. You see, I can show you this way also. You see, here is a negative. This is a positive. This positive and this negative. This battery is negative. This battery is positive. Are getting connected here with a link. So finally, the positive, one positive is coming here. The negative is going here with the white wire. See, there is a wire here. So these two are getting short circuited here. Otherwise, first what you do, check the battery individually. Okay. So now I am going to check the battery individually. So let me see what is that. It is 1.5. So I am going to put the 1.5 into this. Now let me check the other battery. So what is this voltage? It is also 1.5. So 1.5 in series with 1.5. That means this 1.5 positive is going to this here. I mean negative. See, you see, the positive is here, okay, and that is going to the negative of this battery. And finally, the positive is coming here, and negative is going there. So these two batteries are in series. I am going to show you on the paper connecting the batteries in series. Then finally, when the batteries are in series, then how much voltage we must get here? 1.5 plus 1.5. How much is that? 3. So let me check. Positive is here, negative is there. See, 3 volts. See all of you. Hold it. Hold it and see. Hold it. What is the voltage there?
3.
So this plus this is equal to, that's okay, rest other is okay. So everybody has seen that. Have you seen that? Okay, yes. Good. And now I can do this way. Now yesterday in the basic circuit, when the battery positive, what we need to do? When the battery positive, where we need to go? In the basic circuit. Come on, tell me. Resistor or switch, whatever you feel like, no problem. Resistor, better we will go for switch. Okay, we will use this switch or this switch. Which switch you wanted to use? This is better because in our homes and all we use this one. Okay, I am going to use this switch. So battery positive is going to the switch. So I need some support here. So give me one. Okay, I need some support here. Or otherwise, anyway, wait a minute. I need to connect it further, no? So I can use two. Give me 2. I can use this one. See, I'm just using this link too. Okay, I'm connecting. So now my battery positive has come to this, and it is also available here. From here I can go somewhere else. So where you want me to take?
Resistor.
Where is the resistor? Which resistor? Which resistor you wanted to connect?
First.
I don't know the value. See, this is 100 ohms. 3 volts. No problem. This is better. 100 ohms. Okay. So I'm going to use 100 ohms, right? So I can use 100 ohms, right? Okay. Now next after 100 ohms, where you want me to go?
LED.
LED, okay. LED or in a normal bulb? LED, okay. So this is the LED, right? This is LED. So it is going little far. So that's why what we need to do. So I'll just replace these fellows like this. You see what I'm trying to do. So I'm making you understand more better. So here is LED. Okay, I want you to. Okay, LEDs are connected, right? And one resistance also to be connected here. Yes, good. Now finally, I have kept all the required parts for your basic circuit. Is it clear?
Yes, sir.
Is it clear? Okay, good. Now my question is, so is that everything is done? But we need connecting wires. So from here to here, here to here, here to here, here to here, we need to connect.
Yes, sir.
So I'm going to use, because okay, the battery positive went to the switch. Okay, from the switch to resistor, from the resistor to LED. Okay, LED to okay, connected. Now why the bulb is not glowing? The LED is not glowing. Okay, I made it already on only. So LED is not glowing. You did a mistake. Something somewhere is a mistake. Who is going to solve my problem? I am in problem.
Maybe resistor should be here and switch.
No, that doesn't matter. Yesterday we have discussed that switch can be before or after, entire in the circuit, wherever it is okay. Because ultimately the purpose of that switch is to control the current flowing in the loop.
Sir, I think that battery should be here.
No, anywhere battery is okay. The positive of the battery is coming here and from here. And I wanted to troubleshoot. Again, I am using my digital multimeter. Okay, how I am troubleshooting it? You see, I am connecting this negative of the battery. See how I am troubleshooting. Where is my problem? See the negative. This is the final negative. This is the positive. Let me check what is the voltage here. Yeah, it is 3 volts. And is that 3 volts is coming to the positive of this cell? Yeah, it is coming. And this connection is coming to this also. Yeah, of course. So the battery positive and negative, the 3 volts is there. You see, 3 volts is there. So from here, the 3 volts is also coming here. Yes. So there is no problem till this point. Are you all following what I am trying to say?
We should off it and on.
Okay, you should off it and on. What happens, I don't know. Okay, I made it off and again I made it on. Nothing went. Now I am going to see like this. So it's a negative and here it is a positive. It's coming there and it is coming here to the switch point. You see, it's coming there and it is coming to the switch point or not. That's important to me. And why it is not showing? Oh, this is here it must come. When the switch is on, it is also coming after the switch. You can see now. When the switch is on, this is coming after the switch also. You see. If it is off, then it is not coming here. Can someone make it on?
Yes.
Yeah. So it is coming after the switch now. Okay, leave it. Now it is coming. The 3 volts is coming here also. The 3 volts after the resistance, how much is that? That's also coming there. And it is also going here. But it is not allowing, the current is not allowed by the LED. The current is not allowed by the LED. Because yesterday I told you, it must be forward biased. That means the positive must go to the anode of the LED. But today it is going to the cathode of the LED. That's why the current is not allowed going into the LED because it's reversely connected. Now what I need to do, I have to switch off the circuit and I have to remove these fellows, the link fellows, and then I have to change the direction of this LED and I can again connect back, okay, links back, and then I can make sure switch to be on. Yeah. So now the positive is going from here to the switch and then to the resistance and again to the anode of the LED and the cathode is going back to the negative. The electron flow, because this diode is saying, okay, the positive is coming to my anode. That's why I am myself forward biased, so I will allow the current. Electrons can be passed through me. If it is reversely connected, I won't allow electrons to pass. That is what that LED said earlier. అర్థమైంది అందరికీ? మరి మీరు ముందెందుకు కనిపెట్టలేకపోయారు? మన శ్రీనివాస్ మెంటర్ ఎలాంటి జిమ్మిక్కులు ఏం చేస్తాడో అని డౌట్ రావాలి కదా. ఇప్పుడు అర్థమైందా? రియల్ మెంటర్ ఎలా చెప్తాడో పాఠాలు, సీనియర్ మెంటర్ ఎలా చెప్తాడో, నేషనల్ మెంటర్ ఎలా చెప్తాడో ప్రాబ్లం క్రియేట్ చేసి చెప్తాడు. శ్రీనివాస్ ముందే తెలుసు ఆ విషయం. సో ఆర్ యూ ఆల్ ప్రౌడ్ టు హ్యావ్ సచ్ ఎ మెంటర్? నౌ ఈజ్ ఇట్ క్లియర్? నౌ మై క్వశ్చన్ ఏంటంటే, ఇప్పుడు ఇది హౌ మచ్ కరెంట్ ఇట్ ఈస్ డ్రాయింగ్. నౌ ఇట్ ఈస్ ఇంపార్టెంట్ ఫర్ మీ టు అండర్స్టాండ్ how much current it is pulling. That is more important. So how do we understand? So I had to put it in current meter, ammeter, to check that milliamperes, and then I had to open one link and then see this positive, because this is all coming positive like this, and then you see now it is drawing 6.55 milliamperes, almost say 6.5 milliamperes. So whenever I wanted to check the current, then I had to open the circuit, and in between the circuit I had to keep my ammeter. For measuring the voltage, no, I don't need that. Okay, for the measuring the voltage, I need to connect my digital multimeter to measure the voltage across, suppose there is negative point to the positive point. This is called parallel connection. We are not opening the circuit. Okay, we are just connecting parallel. What is the battery voltage? Okay, is the same voltage is after the switch. Okay, switch is working good. Now what's happening? My current is pulled. What is the voltage across after the resistance? It is dropped. Earlier it is 3 volts. Now because current is pulled. Okay, that's why the voltage drop. What is the voltage drop? You can also see like this across the resistance. That and all in next upcoming sessions we will know. Okay, what is the voltage drop across the LED? That is another important point. You all have to understand. So it is dropping around 2.2. So though we are supplying 3 volts, we are applying 3 volts across this in the circuit, but across the LED it is only 2.2 volts. Why? Because the resistor is dropping the extra voltage. Because this mellow is meant for 2 volts only. No? That's why it is taking only 2 volts. The rest of the voltage is dropped by the resistor. So if you wanted to dim it, you have to increase the value of the resistor. You want to see that?
Yes, sir.
Okay, then we will stop it and then open these 2 links and change the value of the resistance. 1K. We will use 1K. Let's see what happens. Now again, circuit. Okay, now keep it on. Now it is so less. The lighting is so less. Because the current flow, because the more the value of the resistance. Earlier it is only 100 ohms. Now it is 1000 ohms. 1K is 1000 ohms. So 10 times I have increased the value of the resistance. Then current will go down by 10 times. That's why the lighting will go by 10 times. That's why you see so much less light. And if I open it, if I stop it and open, come on, give me the next value. What is that? 10K. So we'll see whether it will give any light or not. See, very much less. 10 times much lesser than that fellow. Because that is 1K, it is 10K. So it is 10 times high. So the 10 times less current even than that one. That's why light earlier before with 1K, it is less 10 times. You understand? Okay, now let's see by next resistance. Give me 100K. Now we can go for, we can go for 10K plus 10K. Hey, this is 5.1K, 10K. Give me 10K.
10K plus 1K.
Okay, 10K. See? So it's not at all glowing. Still light, maybe 0.1 milliampere current is going, but that's not sufficient enough to keep the lamp on. Maybe some leakage current is there. But that's not sufficient enough to make the LED on. Just because circuit is on, no? So somewhere, very little current might be going. If you want, we can check it. If you want, you can check it. How much is going. But of course, that is not for your level right now. Next level, okay? Yeah, 0.1 ampere is going. 0.1 milliampere. 0.1 milliampere. So, you understand? So less. That's not sufficient enough to keep the LED on. You understand? Okay. Now, with this, we will go in another way. Again, we will remove these fellows. Okay. Now, instead of resistance, I'll keep that regular normal bulb. Okay. Let me see what happens. L1. L1 is here. Okay. I'm going to keep the regular. So, let me close this one here. Do I need to use a resistance here?
Yes.
No, I don't need a resistance. Okay, I don't need a resistance. Because for only LEDs we need resistance. Because this is a 3 volt bulb only. So I have 3 volt. I am connecting directly to 3 volt bulb. So I don't need any resistance to drop the voltage. But I need a connector here. So which one you will give me? 3. Because 1, 2, 3. 3 points are there. So, yeah. So I can use this one from here to here. Now, Anjana, you are switch it on. Wow! But now I need to understand how much current is pulled by this fellow. And before that, how much current? Okay, I wanted to know. Oh, it is drawing more than 20 milliampere. More than 20 milliampere. It's out of range. It's going out of range. Then, let me see. Next range is to measure 200 milliampere. So let me check this. Yeah, it is. 180 milliamperes. This fellow is drawing 180 milliampere. How much more current? 180 milliampere. That fellow is pulling only 6 milliamperes. But this fellow is pulling. Where is 6 and where is 180? 180 milliamperes. Okay, now we can also check. Okay, we can also check the voltage across the different levels. Okay, let me go to check the voltage. Okay, now what is the voltage of the battery? Keep it on. Okay, what is the voltage of the battery? 3 volts. Now keep the bulb on. Now it is becoming less because the battery condition is gone down. That's why. Otherwise, if the battery is in good condition, even if you are drawing this 200 milliamperes, that must show 3 volts only. But now it is only showing 2.73 volts. That means some voltage drop is there, the battery voltage drop. That is because this fellow is drawing current. At that time, when it is drawing the current, the 200 milliamperes, 180 milliampere, whatever, at that time, the voltage is coming down. So we need to, if it is a good full capacity, full charge battery, full capacity battery, new battery, then that drop won't be. Or otherwise, may not be something like this. These batteries can supply a current of only, they are designed and made for only supply a continuous current of 50 milliampere, and you are drawing 180 milliampere. That's where the voltage drop is taking place. That is also possible. So in that case, we need to go for regulated power supplies. Where if you set a 3 volts, then that's it. Irrespective of currents, the output voltage of that power supply is maintained 3 volts. That's called regulated power. We'll discuss later about all of them. Okay. Now we understood. Without resistance, we are using this. This is regular bulb, 3 volt bulb. That's why it is working. But now you know, no current, how to measure. Current you can measure here, or here, or here, anywhere in the entire circuit. You can open this link and see the current. This is not glowing. Why? Why it is not glowing?
Because connection is not.
The circuit is not closed. Now the through ammeter I am closing the circuit now. Oh, now I kept it in volts mode, no? In the amps mode only it will allow. Yeah, 190 milliamperes it is drawing. So the connection is going through this meter, from the meter it is going like this, and the positive is coming here, and that positive, whatever is going to the meter is coming here, and that positive is connected here, and the negative is getting connected from this. So circuit is getting closed. Then you see the amperes, current, whatever current is going, the amperes are going. I mean the flow of electrons are going. That and all you can see through the meter when you put it in ampere mode, or measuring the voltage and all into voltage mode. You understood now? Is it clear?
Yes, sir.